Hello everyone, welcome to another edition of Calculus 1. Today we are doing a 4.9 antiderivatives. I just call them integrals. Alright, if any of y'all have ever had calculus at all before, like say high school or something, this is a integral part of your calculus experience. There's basically two halves to calculus. You got the derivatives and you got the integrals. And thankfully, they're just one is the opposite of the other. And so, we're going to be doing derivative and reverse. Kind of. So, let's just do an example of what is going on here, and then we'll jump into some problems. So, I got y is equal to x squared. And so, my derivative of that would be a 2x. Everyone's happy with that. Well, what I want to do is I want to go backwards. I'm going to say, what's the integral of 2x dx? Now, hold on. Before I keep going, that's the integral. I'm going to say the integral of, and then again, 2x dx. So that's a big S. You can think of it like you're saying the word sum, because it is a summation, technically. But again, we'll do that another time. That's going to be a whole other chapter. So today, we got integral of this guy. And so all you do is you're going backwards. Guess what? It's going to be an x squared. Wow, really? Plus c. What? You must have the plus c. You must have it. It's one of those things that I forget very often. It's just like limits for me. I just forget about putting the LIM because it's whatever. So plus C, yeah. But in this section in particular, they stress it so much that they give you all kind of problems with it. So just be prepared to do it, and that's fine. I get a lot of my students always reminding me, you got to do plus C, and it's whatever. I forget. It's just the thing. But WebAssign does not let you forget. You're going to have to do it. And that's okay. So how am I supposed to actually do an integral here? Right? Like if I'm just faced with this and I say like, well, what's my answer? How do you actually find an integral? Well, like the derivative, you take the 2 and you bring it down to the front, right? What we would do in this case is we add 1 to the power and divide by the new power. Add 1 to the power. This is very important here. Divide by the new power. And go. So, add 1 to the power, divide by the new power. Basically, I'm going to have that 2x, and that's a 1 power, isn't it? So then what I'm going to do is say 1 plus 1, divide by that new power, that 1 plus 1. And so we got 2x squared, then we got a 2 in the bottom. Well, the 2's cancel, and there you go. Oh, yeah, plus c. Whatever. Okay, so that was so fun. We really like this. Now, what is this plus c in particular here? You know, it's kind of weird. Let me show you another example, and I'll show you why the plus c is important. Let's say I have this guy, and then I'm going to find my derivative. Well, that's 2x plus 0. Cool? Awesome. So then what's my integral of 2x plus 0? It's x squared plus 0 plus c. You can see now the reason for this plus c. It's like a hidden number that somehow got lost along the way, and we just find it again. So how did I know that I either started with, like, here was a plus 0 or a plus 3? How did I know that I started with these numbers? And I don't know. That's the actual thing. I don't know. They just disappeared. And so I don't know what those numbers were. They could be anything. And that's why we put a plus c here. Because it might be something. Here in this case, c is equal to 3. If for me to know that, I'd have to have some kind of additional information. I'm not giving that to you right now. I'm just saying that C is actually, it is important. I know I forget it a lot, but it is important, and they're going to stress that C here in this section, okay? Because going backwards, we might have lost some information, okay? I have a ton of analogies, but I don't think they're worth it for you, so let's just do it. So I have a note here, but you would never know unless you saw the original. Yeah, okay, so we just talked about that. Okay, 4.9.008. Let's do it. I've got f of x is equal to 6x to the 5th, minus 2x to the 4th, minus 9x squared, and they say find cap f of x. Well, what they're trying to indicate whenever you do this is that we should integrate. You know, an integral. Whenever I got f and all of a sudden there's an f prime, they took a derivative. If I have an f and I have a cap f, then they took an integral, okay? That's just notation. And so it's funny here. If you took another derivative, you'd have f double prime. If you took another integral, f. I don't know. There's nothing there. So your integral of f of x dx is equal to capital F of x. This little dx, by the way, he's just notation. He doesn't actually do anything. But it's important because these are like tied together. And you will need to use that understanding a little bit in Calculus 1, definitely Calculus 2, and especially Calculus 3. Moving on, blah, blah, blah. I want to add 1 to the power and divide by the new power. So here we go. I'm going to take my integral. So add 1 to the power. I had a 6 in the front. Now it's a 6 power divided by the new 6. That's a minus. I had a 4 power. Now it's a 5 power divided by the new 5. And then I had a cube. Or I had a square, so now it's a cube divided by the cube. Cancel, kinda. So x to the 6 minus 2/5 x to the 5th minus 3x cubed plus c. Plus c. You got to have that plus c, otherwise it's not going to work. Yeah. I have a note here. It says, notice that add 1 to the power divided by the new power, that thing that I'm doing here, it's the reverse of power rule. It's the reverse of power rule. Okay. Keep moving. So, I got g of v, which is the least convenient letter ever, and then times, or is equal to 3 cosine of v minus 7 over the square root of 1 minus v squared. And they say the integral of g of v dv is equal to capital G of v is equal to what? So we need to integrate this thing. So you know what's funny is that we did add 1 to the power, divide by the new power for my first question. And then the second question here on the homework is basically crazy stuff that we've never seen before. Oh my goodness. Especially this guy. But let's just take this one for the second, and I'm going to talk about it. You know, what I do for my sines and cosines is I have this chain idea. And whenever I take a derivative, I always go down the chain, and eventually I just go back up on the top there of my chain. So this is derivatives. So integrals are the reverse. And so basically an integral is going to be going up the chain, and when you're at the bottom, or at the top, you go back to the bottom. So these are integrals. And so my integral of cosine is a sine. And so my capital G of v is equal to 3 sine of v. Yes, you got to use v's. Don't use x's. And then minus or plus something or other that is there. And plus c. All right, here's the thing with this guy. I'm just going to have to tell you. There are some formulas in your formula book and special integrals and all that kind of stuff, basic integrals, all that kind of stuff. Well, this guy is arc sine of all things. This is the arc sine. Well, so basically my derivative arc sine ends up being this guy. You knew that, right? You knew that, didn't you? Yeah. So, okay, 3 sine of v, minus. It's a -7. There you go, -7. -7 arc sine of v, and then plus c. I'm not making this stuff up. Hey, I've got to give you a strategy for some of this stuff. Can I just tell you the strategy? When it looks crazy and you don't know what to do, go ahead and get it wrong 3 or 5 times, whatever it is, and then look at the answers. Look at what they have. So they have this, and they went to this. They went from here, and they went to here. Can you replicate that? Probably. I'm not saying that you should do this all the time, but the homework in particular is giving you strange questions, and at least it's a start to know, hey, where should I get started? Like, say you're wanting to message me and, hey, can you help me out here, Chad? I need some help on these problems. Well, it's the weekend, and, it's just a busy weekend, and I'm not able to get back to my email very quickly. So, I'm not going to reply within the next 5 minutes. What are you going to do? Are you just going to stare at it? Are you going to skip it? I don't know. Well, just get it wrong and see what the format is. It's a good start. It at least helps you kind of say, how did they get arc sine? And now you can go investigate that. Say like, whoa, what's my derivative arc sine? Or what's my integral of this and that? And eventually you'll figure something out. You're like, oh. Just a thought there. All right, now for the rest of the problems. I got f double prime of x is equal to 2x plus 5e to the x. Because that's an awesome thing to do. And they say use c and d as constants. So c was not enough. Plus c, yeah, they have plus d now, I guess. Well, before we keep going, what's your integral of e to the x dx? It's e to the x plus c. Yay! So just like the derivative, if you take the derivative, e to the x is e to the x. Well, if you integrate e to the x, you get e to the x. So that's an easy one at least. What they're wanting in the end is, like, what's your original f? What's your f of x equal to? So we're going to integrate not once, but twice. So we're going to integrate here to get f prime. So integrate. Add 1 to the power, divide by the new power. And here again, the e to the x goes to e to the x. So you don't change anything. Plus c. That's super important right here, right now. Okay? Well, these 2's cancel, and we're left with this guy here. Okay. Well, we need to keep going. So, integrate again. F of x is equal to... and so now we're actually integrating again. Add 1 to the power, divide by the new power. The e to the x doesn't really change. The c is a constant. Think of it like a 2. 2. Well, now it's 2x. Well, you don't write a 2. You write cx. And then still plus d. This is actually the answer they're looking for. And thankfully, they're not yet looking for what c and d actually are. That'll come in the next problem. So, oh my, 49043. Yeah, okay, there we go. F prime of t is equal to secant t times secant t plus tangent of t. I mean, they are just throwing these guys at you, man. What are they thinking? This is your first time doing integrals, and they're just giving you the hardest ones in the book. And I go and ask my other classes what this is, my Cal3 class. Hey, what's the integral? They won't know. I'm just saying, this is wild, man. All right. So I'm going to distribute, and so this is still my f prime. I got secant squared of t plus secant tangent. Now, if you are a trig expert, that is awesome, and good job. Do you see what the original is? I'm going to take an integral. What is my original equal to now? Well, I'm saying I have something, and the derivative is secant squared. You're correct. The answer is tangent. Oh, I have something in my hands. I'm looking at it, and my derivative ends up being secant tangent. You're correct again. It's secant. Very good. Oh, my goodness. You knew exactly what those were, plus c. there is no cutting around this. It's as if you say, what's the derivative of tangent? It's secant squared. What's the derivative of secant? Secant tangent. You just got to know those. And so now I'm asking, look through your memory and go backwards. Not the easiest, but you'll get used to it eventually. I wish this was the answer, but it's not. They actually have this specific point right here, and that's a t, and they say plug it in and get some stuff here. So -2 is equal to tangent of pi over 4 plus secant of pi over 4 plus c. Solve for c. Well, my tangent of pi over 4 is a 1, and my secant of pi over 4 is basically a square root 2. And so I move these guys over to the other side. C is equal to a -3 minus the square root of 2. And so then my original f is tangent t plus secant t minus 3 minus the square root of 2. This was my c right here that I just found. Ta-da! I did a little bit of shortcuts here and there, but it's all about the same. So 49053, and so I've got f double prime of x is equal to x at a -2. We've got x greater than or equal to 0. This is happy. We'll talk about y in just a minute. F of 1 is equal to 0, and f of 4 is equal to 0. These are also very nice, but not with the ln's that's... Oh, did I just say it? That we're going to about to have in a minute. So, integrate. And thankfully, they put it in this format so it's easier to see when I integrate. I'm going to add 1 to the power and divide by that new power. And so you get x to the... Well, it's going to be a negative x to the -1, because that's going to make a -1 in the bottom there. Plus c. Still got to have the plus c. Now, I have to integrate again, but what I want to do before I do that is I actually want to go backwards in my thought process and make it more complicated. This is a good thing for normally whenever I take integrals. Let me show you what it would look like if I integrated this directly. So I would go -1, I add 1 to the power, and I divide by the new power. And what you have now is x to the 0 divided by 0. And that is not correct. But it should be an indicator that you should be doing something else. And that's how I use it. I do this add 1 to the power, divide by the new power literally every single time, unless it's a trig, which we saw a second ago, and this instance here. Any other time, that's what I'm doing. But in this case, I got this weird answer. That's not going to work. So don't do that. Don't do that. You actually have a better answer. Is that when you integrate this 1 over x business, it turns into ln x with absolute values. Now the c gets an x, and then you get a plus d because of the next guy. But this is the weird one here. So your integral of 1 over x dx is equal to ln of x plus c with the absolute values. Now, you do not need absolute values in this very particular case because of our smiley face over here. Yes, x greater than or equal to 0, well, just greater than 0, means that you can use parentheses here on this problem. I don't think it matters in the end, but it's still important to see the difference between the two. Okay, so this is my original solve for C and D. I actually have some points that I can start plugging in, and these are both original points. Notice just F, not F prime, nothing like that. Sometimes they'll do like an F prime here. Watch out, because that does happen. Not today, though, thankfully. So F of 1, they said it's equal to 0, but I'm going to plug in a 1 and see what happens. So that's all equal to 0. Well, ln of 1 is a 0, so that goes away. So I got 0 is C plus D. I don't know. C is equal to -D. Maybe. And so then I can go back now and rewrite it as negative ln of x. Let's just have it. And then my C is equal to a -D. So I can go -dx plus D. The minus and plus are actually important at this point. I'll talk about C absorbing numbers later. That's not really this section's topic, but like plus C is very ambiguous, and we can utilize that for our own devious properties later. Okay, so this right now we're just trying to stick to the books. Okay, let's use this guy right here. F of 4 is equal to 0. Again, f of 4 is equal to 0. Plug in a 4, so ln of 4 minus d times 4, and then plus d. Solve for d, I guess. Well, we got negative 4 and a plus 1 makes a negative 3d. And so it's all in 3D. Move this guy over. We got ln of 4 is equal to a negative 3d. Divide by the negative 3, and we get negative ln of 4 all over 3. And I can now plug that in right in here. And so I've got negative ln of x minus a negative, so ln of 4 over 3x, and then minus the ln of 4 over 3. Now, that is my answer. This is exactly what I have for my original f of x. And that's good. Mine's just, I took a different road apparently at some point. But that's good enough. Okay. Oh, wow. Do we have applications now? 4.9.75075. Okay. You drop a stone off of a cliff. So there's a stone, and basically you kick it. And it's going to go floop like that. It says that the velocity when it hits the ground is 88 feet per second. Okay? So the velocity when it hits is that. Well, my initial velocity is 0, by the way. I just bloop. Think of it like it just standing still, and then it hits like that. So what is the height of the cliff? They're saying, what's this height here that makes that happen? You know what? Another classic is that you throw a rock off the cliff, and you wait to hear it hit the ground. And that is another way you can determine how high the cliff is. You'd have to do a little bit more math than what we're doing here, but basically that's an easier way, or that is a way to find out how tall something is. Okay, so we got S of t is equal to S naught plus V naught t plus 1/2 gt squared. Yup, you love it. It's the position function. And I think that they were trying to get me to do something else here. I don't really know. But this is the answer that we're going to do, and it's great. So I don't know what my height is. I definitely start with a 0 velocity. And this is a negative. Gravity's making it go down. So negative 1/2 feet will be a 32 that you put in here. And then t squared. And my final position... Oh, actually, it should be a 0, right, because this is 0 right here. Okay, yeah, that's great. Okay, move this to the other side, and I'm going to solve for t, actually. Give me a second. I'm going to leave that alone for a minute. No, you know what? Let's just say h is equal to this stuff here. So that'd be a 16t squared. I don't know if I'll use that. We'll see. So, velocity. So, what if I did my velocity function... Well, I'm going to basically just take S prime, which is V, and take my derivative. So that'd be a V naught plus the 2 comes down to make just a plain old GT. Cool. And so my initial velocity is a 0, of course. And my gravity is a 32. That's a negative 32, technically, right? T. And the velocity that we figured out was 88. Now, this is where it's kind of weird. Notice that, is it a plane 88? Is it? Because if I solve here, I'm going to get a negative t. What? You can't have a negative t. Well, like, if you're looking at it, velocity is actually going to be a negative velocity because it's making it go towards 0. You're going down. Down is negative. So it's not 88. It's negative 88, technically. So that when you divide this to the other side, the two negatives cancel and leaves you with 2.75. I hope. And this is seconds. So that's how long until it hit. Now I can plug that back in up here to find the height, and I got a 121 feet. And I did skip a lot of math to get there, but hey, you know what? It works. Cool. Next question, 49012. So I've got g of t is equal to 3 plus t squared all over the square root of t. And they want to find cap g of t. I'm trying to make my cap g's look a little bit better, I guess. Basically, you're wanting to integrate it, of course. So what is going on here? So what's the opposite of quotient rule, right? Because you got derivative of a fraction and all that stuff. Well, there's not one that I know of. There's not an integral of quotient rule. Not that I can think of. There's an integration land as you'll be working in Chapter 5 and so forth. You find that it's just a whole different ball game. So yeah, don't. How do you solve this problem? It's actually very simple. You distribute your denominator. Now, please remember that isn't the denominator here, so that's going to be a negative 1/2. This is a positive 1. We're going to minus a half, leaving a positive half. And then that's a 2 minus a half, leaving a 3 halves. Okay. Cool. Now, find your integral. Okay, so now we got to integrate this stuff. So integral of all the stuff here is much, much easier. So what do? You add 1 to the power, and you divide by the new power. So now it's a positive 1/2 divided by a positive half. It's now a positive 3 halves over the 3 halves. And then you got a positive 5 halves over the 5 halves. And then, of course, your plus c. You know what's fun about WebAssign is that you don't need to simplify. Boom! I simplified on my paper, but we're done. 4.9.047. F double prime of theta is equal to sine of theta plus cosine of theta. And they say that f of 0 is equal to 4. Here it is. F prime, I warned you about this, f prime of 0 is equal to 1. This is actually a good thing, but it is so important to notice that. And I have a huge note here in my notes. Don't use x. You're using theta. And we are so used to using x that when they try to do v's and thetas and stuff, it just gets weird. Let's get weird, man. Don't make it weird. In my chain, if you go way, way back to the chain, my integral is going opposite. So this is at the very top of the chain. You have to go back to the bottom, and so that's going to be a negative cosine theta. Cosine goes up to a sine, and then plus c. Pause. Notice that we can actually use this right now. So I could say 1 is equal to blah, blah, blah. If I plug... Whoop. It's a 0. It's not a theta. Solve for c. Well, cosine of 0 is equal to a 1. And sine of 0 is equal to a 0. And so if I add this to the other side, c is equal to 2 immediately. And so then my f prime is actually negative cosine theta plus sine theta and then plus 2. Okay, so this is nice. It's a milestone, but we got to keep going. One more time, f. So my integral of negative cosine is a negative sine, and then my sine will go to that negative cosine business, like the last one. 2 gets an x. Whoa, whoa, whoa. He gets a theta. And then a plus d. So now we get to use this guy here. Now it's equal to 4. So I got 4 is equal to all this whenever you're plugging in a 0. I do love plugging in 0. It's a very fine number. This goes away. That goes away. This is a negative 1. And so then you can add 1 and d equals 5. So therefore, last answer here, f of theta is negative sine theta minus cosine theta plus 2 theta and then plus 5. And that is your answer. Whew. I have one last question. We can do this. 49080. It's a word problem. A car is traveling at 50 miles an hour. And then he applies the brakes. And his acceleration, don't get me started on that, is a negative 24 feet per second squared. It's deceleration. No, there's no such thing as a deceleration. It is always an acceleration. It's just in the opposite direction. Sorry, it's a physics thing. Moving on. So we got this negative acceleration thing. So what's the distance to stop? So here's the problem. I got a car, and that's my best car I could ever draw, and it's going 50 miles an hour. And then all of a sudden it sees a turtle. It sees a turtle, and he's crossing the road, right? And he's coming, and so he says, "No way!" How long does it take for him to stop? I guess. So what's that distance to stop? I mean, this is a classic problem that's important to us, right? I mean, the turtles cross the road a lot. We need to make sure that we don't run them over. Okay. I mean, this is legit. They really do cross the road. So let's try to find out what we're going to do here. I would love to do a position formula, honestly, and I think that's what I'm going to do. I'm looking at my notes here, and I'm not going to do it. I'm going to do my own thing for a little bit, if that's okay. We need to convert this into feet and seconds and stuff like that. So 50 miles per 1 hour, and I'm going to multiply this by 5280 feet per mile divided by the 3600 seconds per hour. And what happens is that these hours cancel, the miles cancel, feet per second, do all the math, and you actually get 73.333, and this is my velocity, feet per second. So that's my velocity. That didn't look like velocity. Okay, so position function says that I have S naught plus V naught t plus 1/2 a t squared. Notice acceleration here. It could be a gravity or whatever it is. This time it's not gravity. Okay, and so what I'm wanting to find out is my d. My initial position, let's call it 0. So let's call this 0, and this will be my final d distance and all that kind of stuff. So that makes it easier. My initial velocity was this right here, the 50 miles an hour. So 73.333 t. But notice that I'm not okay, hold on. Is my acceleration helping it go faster? No, it's making it go slower. And so notice that's why it's going to be a negative 24. So minus 1/2 24, minus because there's negative there. I just kind of split it up. And then t squared. And so now I have a distance for however much time it took to make this thing work. Okay. I'm looking around, and yep, we have a problem. Okay, this is great and all. Everything's wonderful, and we will need this. This is great right here. Problem is, what's t equal to? How long did it take him to stop? Go back and read. It ain't there. So we need to know how to make this thing work, and so we actually do have to do integrals. We will come back to this position function here in just a second. Okay, so hang on tight. Let's go on and do our thing for a second. Here we go. So on the side, I say a is equal to negative 24. And my integral of a dt is equal to v. And so when I integrate, I got a negative 24t and then plus c. And this is where we have to understand, this is my initial velocity right here. And it's funny because we already have it. So I'm going to say plus the 73.333. So I just replace c immediately with my initial there. Well, the integral of v dt is equal to s. This is basically the same right here. This is what we had a second ago. And so when I integrate this, I got a negative 24 t squared all over 2 plus 73.333 t, and then plus d, I guess. I don't know. And so this is my initial position. Again, that's my s naught. We already confirmed that that's going to be a 0, so we can make that go away. And they're saying that my position is 0 at t equals 0. Well, kind of already have that. Didn't we just get this same thing here just a second ago? That is my position function. So what did I do? I found t somehow. Okay, so if I factor out a t, I could see whenever my velocity is equal to 0, and that makes sense. All right, I figured it out. It wasn't because of the pause, though. Basically, I'm wanting my velocity to be equal to 0. I want my velocity to be equal to 0. Isn't that basically my car is stopped? And so if I find t here, I can go and plug it in back into my function. Well, I know that these are duplicates. You don't really have needed to do that at all. But let me solve for t here. Blah, 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 math. And you get 3.056 seconds. And then you could take that and plug it in here. And then we get my answer. My d is the 112.0, I think rounded, feet. That's my total stopping distance. All right, and now we're done. Whew. So, and then we did all those additional problems, and good. All right, cool. Well, we're done finally with chapter 4 point everything, and I guess the next one up is chapter 5 eventually. So, thank you very much. Have a great day.